So now the next speaker is Stephen from Varga and Consulting, who will give us a rundown on H5CPP, which is different to H5CPP at DAISY, I think.
Yes, indeed. And there is this naming conflict going on for over the past 3 years. And seriously, I am considering to find a better name. So if anyone from the community have great suggestions, I may just take it someday. And that day will come pretty soon, as I'm coming out on the newer version of this system that will support the standard template library in a different manner that as of now, keeping up with the development, recent development in the C++ as a language. Allow me to share my screen and
the screen is yours.
With the share screen. And I think this is the one. Share. Let's go with it. It's a great pairing to have this presentation right after Thomas's, as this project in some way connected to Python or other languages in a way that it aims to improve on C++ or possibly C code in terms of linguistics, expressiveness, and without the trade-offs when it comes to speed. So this project is about 3 years old, is in collaboration with Gert Heber from the HDF group. We regularly have discussions and trying to improve on the project, some corner cases, if there is any. Meanwhile, I'm working on the main idea to bring a non-intrusive persistence to C++, which basically means you should be able to do similar things in C++ that you already can with interpreted languages such as Python, Java, and so on. So let's take a look at what that actually means. If I can fit it on my screen, I'm not quite sure. I could remove this little window from the presentation slides. So what basically this project provides is an MPI. Let me start this timer here. Excellent. So it's an MPI or enabled or serial HDF5 enabled system. That's basically the data backend. It does support popular linear algebra libraries such as the Armadillo, Eigen, Blitz, and you name it. If I missed your C++ linear algebra library, please get in touch. I will add them. It's very minimal work as it exploits structure. Now it does that with CRUD-like operators, and here are the list. It's easy to remember: create, read, write, and for the data operators there is an append. For the actual attributes, it's even simpler. It does provide an RAII mechanism to manage resources. Similarly, Python, you don't have to worry about whether your resources are released or not. It does come with structured exceptions. You can start from the very simple catch all, catch any, and you can go down to the details to the specifics that you are interested only catching some IO exceptions related to some specifics. There's a detailed documentation on these ones. We'll get to that later. It does come with a separate high-performance packet table. I use these systems in soft real-time settings for trading, stock market, financial settings where it is important to have good properties in terms of latency and throughput. It is based on a LLVM infrastructure. There is a separate factored project, the H5CPP compiler, which I am moving towards to more template-based solutions. And finally, hopefully someday, when C++ converges to purely template-based introspection, then this project will be one of the first that is capable of catching on and keep up with the space. So let's take a look at what it actually does. So here is an example where it provides a quality persistence. Only a few lines I will walk you through the example, but this is a high performance event processing pipeline. It could be actually an image sensor, alternatively sensor networks and whatnot. It does provide the Pythonic syntax. What basically means is that when you're specifying dimensions, you can just roll in 1, 2, 3 dimensions or defining the ranks, and metaprogramming framework will generate the right amount of code and not more. And there is daisy chain mechanism for flags or property lists. Of course, arbitrary order, they do the right thing, whatever you actually intuitively you meaning it to do. Similarly, there are some knobs and levers, that's all of them, that whatever the HDF5 underlying HDF5 system provides, that's available to you. And one of the interesting features is that you can throw your arguments in arbitrary order without actual runtime trade-offs. Similarly, Python, this one uses template metaprogramming approach. And basically, there may be a slight penalty in terms of like compile time, but overall it checks out. There is no performance penalty when it comes to runtime. So let's take a look at this example here. This is the actual operator, H5 append, that takes a resource, descriptor, a handle, PT, in this case, packet table, and some data. This data can be a single event, could be a frame in an armadillo matrix or vector, or even multiple slices. Eigen comes into my mind when you want to record image frames. In this, what you see is some complicated structured event that you want to save into some HDF5 container. You're obtaining a handle to it. And then, of course, you need some data set that you created with some properties. And that's all there is to it. And of course, something goes wrong, you will be sure that that's still a handle. So what behind the scenes, what actually drives this? And actually introspection. Currently not yet available in the C++ library. And in order to make this happen, one has to pull up the sleeves and get to it in lower level. In my case, I used the LLVM infrastructure to write H5CPP compiler. And what we actually doing here is we generating this header file that is sandwiched between the core and the IO header ports. So how does it work? In the first phase, we invoke the compiler and TU translation unit. Of course, multiple translation units are allowed. And any objects, supported objects, which are referenced by the operators, create, read, write, or append, similarly for the attributes, are scanned, singled out, and processed in actually reverse topological order, producing this output, which comes with include guards, just to keep things nice. And you want to work nicely with others. So in a namespace, it uses template specialization to do the actual job, which is to produce this type descriptor code block for the HDF file. This basically is the serialization mechanism, as what we heard yesterday in the DAISY presentation. That basically, in this case, works out of the box. And of course, there is some mechanism to insert this one with the templates. In the second phase, you just invoke your regular compiler. You'll get to it what they can be. There is technically no restrictions other than the C++17 flag that you pass in alone. Then you link against your HDF5 library. there is no dependency to the high-level library, just only the plain single lib HDF5 and passing along the additional dependencies if you have any. So how complex can these structures be? So what we see here is some complex structures in the upper side, and this is the actual object that you are referencing to, and or you do I/O operation on, and this object references some other structure here, yeah, as an array, and there is multiple embeddings here. No problem, it works out of the box. So there are examples on the web page, on the H5CPP web page, as well as I do solve some of the interesting problems if I come across on the HDF5 user group, where I am considered rather active. And in this case, if you follow these links later on, if you have any interest, and then you actually can get to some of these projects or some of these sketches that actually I solved previously. And if you have any problems regarding this performance issues resulting using the C API or H5CPP, this specific version, then you can get in touch on the user group. I'll take a look at usually your problem, and if it's unique, has not been solved yet, then I will possibly come up with a solution. So this is a typical example for comma-separated values. It comes up rather often. I'm using here Ben Strasser's header-only library to actually parse the comma-separated value files. There is some backing structure which describes the rows, and you have to include some with header-only parts of the H5CPP system. Then you have your translation unit. In this case, is a main program. You don't want to drag it out. This is not like a one-week project, more like 20 minutes or an hour. You create your container, you create your data set. In this particular case, I did an explicit conversion from a data set to packet table, but implicitly you could just use a packet table descriptor right here. It would just do the writing. Then we add some sideband information with the attributes, and there we have it. This is your high-speed high performance packet table implementation. Speaking of attributes, there are different ways of managing them. You can pass scalars, vectors, linear algebra objects. You could use initializers for that matter, or just pass plain strings of some kind. So here are some templates for you. They look rather complex, even in eBNF notation. Luckily, there is a rich documentation provided here, mostly based on the HDF5 C API documentation. And you should be able to find your ways. There are some built-in heuristics, such as very small data sets are in the compact layout format, how to achieve a contiguous layout by default, and whatnot. If you're wishing to use custom data types, there is a mechanism to do these ones. It's very simple. It works. Here is a list one currently I am working on, which is more like a research to achieve like a really good string handling for cases where it actually matters. And I don't mean like a few million strings, but I mean like massive scale, possibly giga 2 terabyte size. Better heuristics for compact and contiguous chunk layout. These are already in the developer branch, scalar arrays and ragged arrays, which is important for some applications. And there is actually a whole list for these ones. So here are some I/O properties. These ones are my older laptop, done on my older laptop a few years back then. Basically, what you see here with the numbers is the results are in the same ballpark as the underlying file system. that's basically there is to it. There may be a few ticks to shave off, but basically this system will produce you the same CAPI calls to generative programming what an expert would write in C. So few compilers that I am testing against. If someone from the compiler community and missed that one, please get in touch. Here is a list of applications, financial markets, of course, real-time bidding, medical and biotech, and machine learning and whatnot. But most importantly, this is a system that allows you from moving from prototype, give you an example from H5Pi to production quality code. And that's what this non-intrusive persistent system can bring into your life. I'm ready for your question if you have any. Thank you very much.
Thank you, Steve. There were no questions in the chat yet. There was someone has one. Is static introspection emulation tightly coupled with the library, or can I plug in mine? Say boost describe.
Well, possibly not. I would ask first of all, like, why would you do that? As boost is something like a massive scale. This is very thin. What there is for you is the boost linear algebra library is supported. So you could use that one. So whenever you're using boost and you want to save vectors or matrices and whatnot, you could just pass that object along and it will do the right thing. Of course, many other linear algebra libraries supported. In fact, most of the popular ones. But if I missed yours, then please get in touch.
Okay. And how dependent are you on the version of HDF, of libHDF?
There is no actual dependence. What there is whether the header files, what the published functions, the symbols inside are matching. But basically, this is a generative programming approach. This is a header-only library. This is a very new architecture. What it actually means is with some template metaprogramming magic, with generating the C code actual that your experts would write. Mm-hmm. Okay. There are some, you can imagine a terrain where there are valleys. These are your lowest potentials. This is where you want to travel to get to the optimal lowest point. Speaking of optimization, or you can invert the inverted surface for the maximization problem. And basically, you're finding these valleys and then you traverse within. That's what's happening there to provide optimal code.
Very interesting.
I am from the optimization community, and for these ones, there are some of these ones are hard problems, but with heuristics, one can approach or attack some of these corner cases and take the case that actually provides a near optimum output.
Okay.
So a very quick question.
Yeah.
If that's okay. So how do you said you have optimal code. How do you measure how fast things are, or if it's optimal? How do you know?
Great question. So if yesterday you perhaps, I'm not sure if you were present, I was presenting a benchmarking library that actually measures your target. Now, I have been measuring it in different ways, but this newer version will some way create some sort of a coupling that can be done in a very efficient way. And I'm also working on something called the mock library. It's within the current H5CPP distribution. I'm factoring it out. Possibly people seen H5 random, which basically as a preferred sequence-based tree generation algorithm that generates like a random massive scale trees, and you can test against. It will be coming out somewhere like possibly 8 months where it's going to be production ready, where you actually can use it. This is a complex problem. You have to factor out the data generation part, the mock library, then you have to have a good fitting benchmarking facility. That's what I'm also working on. And then again, there's actual library that you're measuring against. It's a complex
Okay. Stephen, thank you. Definitely non-trivial. I still have to get my head around all of this.
This is non-trivial. This is a bleeding edge.
Yeah,
and it will be, I think, in a few months when I'm coming out with a newer version.
Okay.
That H5C++ can be. Thank you very much for the opportunity for everyone.
Thank you.